When we look out at the night sky and see the stars as points of light, it's hard to reconcile those points with objects like our own sun. But that's simply what they are, just very, very far away. Our own sun is the source of all the energy in our solar system. At its surface, it's several thousand degrees hot. It's actually a big ball of gas with no conventional solid surface. But all the action happens deep in its core, where the temperature is 15 million degrees. It's so hot that hydrogen can fuse and produce energy, which powers the sun. And how big is the sun? Well, it consumes hundreds of millions of tons of hydrogen every second, but it can do that for 10 billion years. We can't see the core directly, but we can see the outer chromosphere and corona, and we can sometimes see ejections from the sun, producing solar storms. The sun is kind of intermediate in temperature between very hot and very cool stars. It's kind of yellow. Extremely hot stars are blue, and extremely cool stars are red. So it's the opposite to what you have on a tap. This is our nearest stellar neighbor beyond the sun. It's called Proxima Centauri. The sunlight takes 8 minutes to get to us. From Proxima, it takes 4 years. It's 250,000 times further away. And Proxima is the most common type of star. It's a red dwarf, not much bigger than Jupiter, but compared to other members of its system and our own sun, it's a baby. Now, the sun is colossal, but it's what we call a dwarf star. We call it a dwarf star because there are stars which are 50, 100 times bigger, and then we call those giants, usually red giants. There are some hot blue stars, which are very bright. There's blue supergiants, which are hundreds of times bigger. But the biggest of all the stars are the red supergiants and red hypergiants. These can be 1,000 or sometimes even 2,000 times bigger than our own sun. How big is that? Well, if you were on a jet airliner circumnavigating it, it would take 1,000 years non-stop. In between the stars, there is dust and gas, and this image of the Horsehead Nebula illustrates the gas and the dust. And it's in very cold, dusty, dense regions of our Milky Way and other galaxies where stars are forming right now. Here we can see pillars of dense gas and interstellar dust, which is like soot, illuminated by nearby young massive stars in a region called Carina. Newborn stars start off cool, and so they're must easily seen in the infrared part of the spectrum. This is images of the Herschel telescope, which samples cool infrared light. The nearest large star-forming places in our Milky Way to the sun is in the Orion constellation. This is Orion on its side, as viewed from Sheffield. If we look at Orion's belt and go down to Orion's sword, the fuzzy thing in Orion's sword is the Orion Nebula. And in Orion, we have something like a couple of thousand stars, some of which have already formed, but most are still forming. And this simulation, based on real information about the Orion Nebula, takes us on a journey through this stellar nursery. And so there are some stars which just recently formed here, but there are other regions where stars are still forming. And where the stars are still forming, we think they form with this disk around them. And here we're zooming in on one such region where the star is forming in the center, and around the edge in this disk, we think things like the gas giants made out of the gas, like Jupiter, and the rocky things made out of dust, like the Earth, could well be forming right now. So in our next section, when I return, we'll be talking about the death of stars.